Okay, so we know two sides of a right triangle and we are asked to find the missing side. Whenever we state the Pythagorean theorem, we should know who is the hypotenuse, the longest side, because that's the one that needs to be alone on one side of the equation when we state the Pythagorean theorem. The problem was not specific enough because we don't know whether the side missing, x, is a hypotenuse or not. One thing that we know is that 9 cannot be the hypotenuse, right? 40 beats it out. So there are actually two pictures with two different equations that will give you two different solutions. One of them is when x is the hypotenuse. So you have a shorter side 9, another shorter side 40, and x is the hypotenuse. And then the Pythagorean theorem says that 9 squared plus 40 squared equals x squared. But that's not the only possibility, right? X could be less than 40, and then we have a triangle where 40 is the hypotenuse and 9 and x are the other two sides. Then the Pythagorean theorem for this triangle is x squared plus 9 squared equals 40 squared. So now let's solve these. We have 81 plus, so it's 1681 equals x squared. All we need to see if 1681 is a perfect square. That we need to know. So if we take the square root of, which I believe it won't. No, I'm wrong. So x is 41 or negative 41 based on this equation. This here is what I need to see. This tells me that if you have an equation that says x squared is 1681, you do know that that has two solutions algebraically. But the negative one is ruled out because distances cannot be negative. That I see from the arrow. For me, the arrow will mean that we're looking for the distance, the negative 41 is ruled out. But I need to see this distinction, that you understand the difference between the algebraic result and its interpretation within the context of the problem. Okay? One possible side length is 41. All right, let's see the other one. And this other one, x squared plus 81 is 1600. So x squared is 1519. And therefore x equals plus minus square root of 1519. So x is plus minus square root of 1519. And then we check square root of 1519. So the square root is not an integer, which means 1519 is not a perfect square. We got 38 and change, almost 39, but no one cares because we have to use exact values. Exact values means the decimal is useless in case of a number like this. And so this equation has two solutions, square root of 1519 and its opposite. And then we interpret it within the context of the problem, which means we kick out the negative one. And so these are the two solutions. The problem didn't specify whether x is the hypotenuse or not. So given two sides of a right triangle being 90 and 40, these are both possible. Thank you for watching.